Hello and welcome everyone. Today we are diving into the different types of tokens that exist on your favorite blockchain. So in this video we'll start by clearing the basics. What are coins and why they are fundamental to any ecosystem? We will see how they are used through something known as the native transfer, which operate across all blockchains. Next we will explore how tokens can be created, beginning with the contract-based tokens. Here we will learn about the ERC standard on Ethereum, that revolutionized how tokens are created and evolve on the blockchain network. And then we will discuss both the technical capabilities and the limitations that come with these tokens. After many years, we have enough adoption and we have enough data to see how things are going on. After that, we'll switch gear to protocol-based token, taking a closer look at the ESDT standard from Multiverse. This segment will help us understand the potential for technological evolution in blockchain and examine whether this newer standard can truly improve integration and interoperability between different blockchains, without losing capacities or anything that we need already. By the end of this video, you will have a comprehensive understanding on the various types of tokens, how they function, and how they contribute to the broader blockchain landscape, including the builder adoption. So without further ado, let's get started and unlock the complex world of blockchain token. Even if this term might seem a little bit old-fashioned, if you ever made a transaction in Web3, you definitely encountered coins. These are fundamental to every blockchain, tracing their legacy back to the reason behind Bitcoin. So let's break it down using it as our example, but remember the principle here applies to all blockchains. So here we have a user that created a wallet using their favorite tool. MetaMask, Ledger, Xportal, any wallet. Essentially, this wallet is a cryptographic key that gives you ownership on an on-chain address, allowing you to sign transactions and submit them to the blockchain by paying fees. But this address tracks also various variables linked to the wallet, which the protocol uses for different kinds of interaction. But the most important one in our situation and in the people's minds is the balance, the amount that you own of the native token. Every wallet in Web3 can hold this native amount used to pay transaction fees. For example, BTC on Bitcoin, ETH on Ethereum, Matic on Polygon, or EGLD on Multiverse. This value is directly owned by your wallet and requires your private signature to move any amount out of it. Similarly, if a friend has their own wallet, they can also hold a BTC balance and submit their own transaction on the blockchain network. The main features that everybody knows is a coin transaction, allowing the transfer of part of this balance from one wallet to another. This was a revolution created by Bitcoin, the secure transfer of digital value. This process is called the native token transfer, where we move the fundamental asset of a chain between wallets. Every address in Web3 can transfer this value to another by paying a small fee to the network, which is then recorded on the decentralized ledger maintained by various validators or miners for the different blockchains. Now that we understand the basic features of native assets and their role, you might think the same approach is used for other tokens. However, this is not entirely true, due to some technical challenges. A workaround was found with the creation of the first token on-chain through Ethereum, which introduced programmability and the ERC-20 standard. This revolutionized the blockchain space and has been adopted by many blockchains since, enabling the creation and exchange of tokens while introducing complexity still unresolved today. So let's switch to Ether and see how contracts provide the capacity to create tokens and exchange their value between wallets. Let's go. So this time we will dive into ERC-20, the standard for contract-based token on Ethereum. We will look at two wallets holding ETH natively. It is not important to follow how much, we will not cover fees here. It's important to notice also that other blockchains, like Binance Smart Chain, Solana, Polygon, and Avalanche, to name only just few, use similar approach in their protocols. The concept is to have a smart contract deployed on-chain that will track who owns that. So the main purpose of this contract here is to store the amount of token owned by each wallet. It provides also various ways to interact with these tokens. While some functions are specific to certain blockchains, we will focus on the common ground, the ERC-20 contract, that is commonly used on a lot of different blockchains today. Essentially, there's three main functions that a user can interact with. First, you can check the token balance for any address. This is the reason why you need to add the contract address to some wallet to see the amount of token that you actually own. So when you first acquire a token, the contract updates its internal state to reflect the new balance. This can happen through transfer, minting, airdrop, anything that you can have in mind. The ERC tokens don't need explicit account creation. Any address can receive token, and the balance is stored within the contract internal state. Let's imagine our first user has received some tokens and now wants to use the second functionality, the token transfer. The same way you receive token initially, you can transfer a portion of your balance to another address. This process is known as sending token on a blockchain. Classic. The final function that often sparks debates on social media is the ability to delegate permission to manage your tokens. To illustrate this, we need another contract. Typically, you don't delegate to another wallet, but to a contract that can interact with your token. So as we see how interaction occurs between wallet and with contract, regarding tokens, we need to make some space to add a new actor on our example. Let's see how a simple stacking contract works, which allows users to deposit their tokens and receive a reward periodically. We will leave the reward aside today to keep it simple. So like any other wallets, the contract will have an account on the ERC contract. When you stack token on a stacking contract, it transfers the stacked amount from your balance to its own. This is where delegate permission becomes crucial. I feel like I need to clarify. As a user, you must first grant permission for the stacking contract to interact with the ERC contract on your behalf. This is done by using the approve function and giving the address of the stacking contract as a parameter. It is possible to limit this permission to a certain amount, but it's not really used by the DApp and even less by the thief. Once permission is granted, the stacking contract can manage your token for you when you send a stacking transaction to it. From now on, if the execution of the code decides to take your token, there is nothing that you can do. With bulk transaction and low fees, it's easy to approve multiple contracts at once and lose the most valuable assets on your portfolio. When you stack your token on a stacking contract, it interacts with the ERC contract to transfer the stacked amount from your balance to his own. Another critical aspect is the contract administrator, the owner, the one that deployed it, who has access to additional functionalities. This can be often obscured and require technical knowledge to understand them fully. This is a significant security concern. Scam often occurs when user connects to fraudulent project dApps or fake replica of popular ones. It's easy to unknowingly sign a transaction that grants access to all your tokens across the network, leading to potential loss of all your funds. This can depend on the configuration of the contract, but admins can perform advanced functions like contract upgrade and other hidden commands, which underscore the importance of understanding the permission you grant. It is important to notice that the same approach has been taken for NFTs, with most relying on smart contracts for ownership management. However, innovation in recent years have changed the approach to something totally different. The ERC-20 standard has enabled a wide array of applications, from decentralized finance, governance token, and a lot more, but it also introduced new security risks and complexity. While ERC tokens offer programmability and flexibility, they require users to interact with smart contracts, which can lead to vulnerability and administrative complexities. Understanding this interaction is crucial for secure and effective use of ERC tokens. Despite these challenges, these tokens remain a cornerstone of the blockchain ecosystem. Now let's explore a newer approach with protocol-based tokens, especially focusing on the ESDT standard for multiverse X. So now let's explore this protocol-based token standard. This recent approach is taken by few deployed blockchains at the moment, like Multiverse X, Polkadot, or Cardano, which decided to implement the management of their token at protocol level. Again, I will try to remain generic in the approach and go through the concept, but I will take the ESDT for Multiverse X as an example. We have here the same configuration as our example with Bitcoin. Two users with their X-Portal wallets owning a little EGLD on their wallet. They can exchange it through the protocol like any coins on any respective chains with the native transfer again. This native transfer works exactly the same way as on all the other chains. The difference comes from the fact that all these wallets are also capable of holding additional values. They represent the amount of token that you own on your wallet, available to you and remaining secure because requiring your personal signature to move them out. Because of that, it is possible to see a list of all the tokens owned by any address directly on your Explorer. The beauty of this is that it extends to the NFTs, and it is possible to have new features in the future. Any idea that we require on protocol level could be added. There is no additional logic required to execute a transfer of token than our two wallets using the protocol itself. In the case of Multiverse X and the state charging infrastructure, this feature makes even more sense, but it's another topic. This capacity, even if it seems like something basic at first, creates important differences in terms of interaction logic at the heart of the blockchain, offering optimization and simplicity without requiring a contract to act as a middleman. The protocol-based standards makes token management safer and more intuitive for users. Unlike traditional contract-based token, you don't need to know about or interact with any contract to manage your token. Your tokens are directly available within your wallet. This means that all the tokens that you see in it are secure and cannot be moved without your explicit signature. And this is, from my point of view, a step forward true ownership of your assets. Imagine the peace of mind knowing that your tokens are safe, directly accessible in your wallet, and cannot be transferred without your approval. This user-friendly approach eliminates the need to verify balance through smart contracts, making the experience seamless and straightforward. Let's take a look at how this impacts integration with smart contracts. We will not need a second user for this, so let's make some space and welcome our stacking contract. Like I said a few minutes ago, every addresses on the chain can hold assets on the protocol level, and that includes smart contract ones. It means that our stacking contract can directly receive tokens without the logic required to call another contract or anything like that. In fact, depending on how you implement your contract, the simplest way would be to add a stack function, an endpoint, callable by the user that accepts your ESDT. It is then possible to sign a transaction to transmit an amount of token and call the stacking function directly. Et voilà. As simple as that. Now the tokens are owned at protocol level by this contract. The only thing that needs to be done is to add the logic to calculate the reward and to add some endpoint to claim the reward or redelegate them. But that's all. Thanks a lot for following until the end. We've explored together the role of coins within blockchain and discovered the complexities and capabilities of contract-based token with ERC-20. At the end, we've examined the innovative approach with protocol-based tokens with the multiversic standard. We learned that while traditional ERC tokens offer programmability and extensive use cases, they also introduce certain complexities and security concerns. On the other hand, ESDT tokens integrate more seamlessly into user wallets, providing a more natural and secure user experience by simplifying token management and improving the transaction safeties. The evolution from contract-based to protocol-based token standards like USDT represent a significant shift on how blockchain technology seeks to balance functionality, security, and user-friendliness. It's clear that as blockchain technology continues to evolve, the mechanism for creating and managing tokens are also improving, making this digital asset more accessible and safer for everyone. Remember, whether you're a developer, an investor, or just a curious mind, staying informed and understanding the underlying technology is crucial as you navigate into the ever-expanding world of blockchain. I encourage you to continue exploring, learning, and participating in this digital evolution. If you found this video helpful, please like, subscribe, and share it with others who might be interested in the fascinating world of tokens in a blockchain technology. Your support helps us bring more content like this to you. And if you enjoy it really, you can further support us by stacking your e-gold on our crypto-based stacking provider pool on Multiversix. Until next time, keep exploring and stay safe in a digital world. Bye!